you've got the biggest idea ever. It's going to be hundreds, maybe thousands of IoT devices. Each one of them needs to talk to each other, and each one is in the field. You need a network of communication that you can rely on. More importantly, you need one you can afford. Is there such a thing? There sure is. What's it like? That's what we're going to talk about on this episode of Dev Radio. Hi, and welcome to the next episode of Microsoft Dev Radio. I'm Jerry, and I'm here with Bret Stateham all the way from California. Bret, I got to tell you, you're my favorite evangelist, and not just because you're the smartest one, just because you're the best looking. There's no getting past.
Oh, wow. I'm humbled. Thank you.
Man, if you had a quarter for every time.
Yeah, right.
Let's see. Bret, we're here to talk about a project, but I want to talk about you for a second. I haven't had you on the show very much. I don't know if people can appreciate just how broad and diverse your skill sets are. Tell me what you're focusing on right now.
Lately, I've been focusing a lot on the IoT stack up in Azure. That really means sort of two things. One, I get to play a lot with the devices, so I'm into microcontrollers and Arduinos and Raspberry Pis and all that kind of stuff. But that also means really the whole Azure stack behind it. You know, once you get a message from an IoT device up into, let's say, an IoT hub, really the entire sort of Azure stack just sort of opens like a blooming flower, and you just get the whole beauty of Azure behind that. So IoT really is just sort of a gateway drug into Azure.
That's right.
Gets you
it's either a blooming flower or an avalanche, depending on how you look at it.
Yeah.
And there's another service we can use. Now, way back when, we were creating, remember that give sign with all the lights would light up? That was hilarious. But the biggest thing that you've been working on lately is the Mars project, this cool little box. Tell me just a little bit about it.
Yeah, so this is actually an event series that we've been running. Actually, it'll be global, that gives the premise of we've got a crew on a base on Mars, and we've lost contact with them. And so we're going to use a number of Azure technologies to try and reestablish communication with them. And so in this first go-round of the event series, we're using Azure IoT Hubs to communicate with the coffee pot on base. And so we have a top secret technology called quantum entanglement. I shouldn't have said that. But anyhow,
we'll cut it out in post-production,
right?
No problem.
So, but as attendees in the room try to communicate with the coffee pot, we have a local sort of quantum entangled device twin that sort of mimics what the coffee pot on base is doing.
Nice. If I can do it to this coffee pot, it'll happen to that.
Yep. And so then we also play around with Azure Functions and Azure Cognitive Services and some cool sort of different experiences for the attendees than the normal heads-up type presentations that they might be used to.
Okay, Bret, but we've also got Josh on the phone, and he's here to talk to us about something totally different. Josh, thanks for being on the show. You're the VP of Product Management at what company?
I'm at Ingenu.
You're at Ingenu. Now tell me a little bit about, before we talk about Ingenu and all the cool stuff that you've been doing and working with Bret, tell me a little bit about who you are, kind of where you are, and kind of just introduce yourself.
Absolutely. As you mentioned, I'm VP of Product Management at Ingenu. I'm coming to you today from our office in Scottsdale in sunny Arizona. So my responsibilities as VP of Product here are, of course, to maintain and to run our internal product lines, and we're doing everything from hardware components, radio modules, and chipsets, to some of our software programs. Some of those we'll be talking about a little bit today. But the other key component of my responsibilities are working with our ecosystem partners, like Microsoft in this case, so that we can offer our customers that are using our technology a complete end-to-end solution. And I think we've done that a little bit with what we've done with Bret over the last couple of months.
Nice. Outside of quantum entanglement, did you used to be a software developer, or what do you do? What drives you?
No, actually, I was not a software developer. I've worked in the IoT industry for about 10 years. Several of those years I worked in as a market research analyst. So I've been covering the market for several years. gotten to know all the key players in the market, worked with a variety of the partners that we're working with today and in other capacities. So that's kind of my background, and I've been with Ingenu for about a year taking on this responsibility. And as we get into, we have some really lofty goals, but I think we're going to achieve those with some of the pieces we have in place.
Nice. All right, let's talk about, there are bound to be a handful of people listening and watching that don't know about Ingenu. Tell us just a little bit about the company.
Sure, absolutely. Well, as you can probably tell by what we talked about today, you've heard of the Internet of Things. That's the space we play in. What we're doing specifically is building a global, the first global worldwide wireless wide range network. Wow. So specifically designed and developed for machines, which are really the things in the Internet of Things. So the types of devices we're talking about could be utility meters, soil monitors, pet trackers. Really, the possibilities are endless. What our technology could be used for. So how do we do it? We utilize our exclusive technology. It's called RPMA. That stands for Random Phase Multiple Access technology.
Okay. Wow.
I know it's a mouthful.
Yeah.
But RPMA operates on the 2.4 gigahertz spectrum, which has the advantage of being available in every country and free in every country in the world, which is one way amongst many others that we sort of stand out from the cellular technologies, which have long sort of dominated the IoT market. And really, those technologies are just a poor fit for IoT. They're expensive. They consume too much energy. The networks get shut down on a regular basis, and all the things that RPMA is not. And really, in my opinion, those technologies have really held back the growth of IoT in recent years. We have all these really interesting and cool devices and applications being developed by developers all around the world, but they're forced to rely on these older technologies that just aren't suitable and don't meet the requirements of their applications. So that's where RPMA comes in. I won't go into all the details, but I mean, things that we offer are greater capacity, better coverage. We don't sunset our technology. When we make enhancements, it's always available. Older iterations, devices will still work on it. So you're not going to be shut off our network. Inexpensive. Those are just some of the advantages that we can offer with our technology. So at Ingenu, we're deploying RPMA networks around the world. Here in the U.S., we have over 30 markets covered already, with many more to come in upcoming years. Globally, we're working with licensees who are deploying RPMA networks and building RPMA networks in several key markets already, like South Africa, Italy, and China. And so the footprint of RPMA, the coverage footprint of RPMA, will really continue to expand in the upcoming years. So that's Ingenu in a nutshell. We obviously have some very lofty goals. We don't have any plans yet for Mars. To Bret's earlier, so maybe we'll put that on the roadmap somewhere. But certainly, we think with the technology we have in place, with the people we have in place, we can achieve those goals.
Yeah, that's awesome. That is absolutely awesome, and solves a serious problem. I mean, I want to turn a light on the other side of my mountain. I've got to suddenly, tie on a cell phone in order to contact it remotely. This is beautiful, absolutely beautiful.
If you have cell phone coverage in that area, which is unlikely.
Yeah, that's a great point. That's actually a terrific point. That is so funny. This harkens back to like a million conversations I've had. All right, terrific. We'll talk about that just a little bit more.
Okay.
All right, Bret, talk to me about the project. How do we run into these guys?
So I actually met Derek Hatch, who's your VP Product Dev.
He's a head of our hardware product manager.
Yeah. So I had the opportunity to meet Derek at LA Hacks out at UCLA back in 2016, and so Ingenu was sponsoring, and they had some of their devices out there trying to get students sort of interested in building, low power wireless solutions. So that was kind of cool, and we had a conversation about what their platform was, and I said, man, wouldn't it be cool if we could get those messages off those devices, into Azure. So that really started that whole conversation. And so we had the opportunity this year to work with Josh and his team. They got me some hardware, and sat down and sort of hacked together a solution between when I got the hardware on Friday and when I was supposed to demo it on Tuesday. So we sort of put together a hack solution, but it actually it mimics sort of what the normal Ingenu customer pattern looks like today. And so we got that built as sort of the first phase, the proof of concept, I think we called it, right?
That's right.
And then we're working with a third-party partner to try and carry that project further and get tighter integration between Ingenu's Intellect platform and into Azure.
Okay. Now, tell me, Josh, what's the Intellect platform?
Intellect is essentially Ingenu's device management platform. So it's a single platform that you can do everything you need to manage your device. You can monitor device usage. You can set notifications if that device usage meets a certain parameter and you want to be alerted to that. You can take actions like activating, deactivating, suspending devices. So it's really just a single platform for anyone that has an RPMA device out in the field, whether it's 10 or 10,000, to be able to manage those devices. So an important part of it is, though, Intellect is one piece, but we realize it's not the complete solution. We need to work with third-party platforms to really take all the data and all the information that's kind of passing through Intellect and expose that and present that to the customer. And so to allow that, we built in several interfaces into Intellect, REST and AMQP interfaces specifically, so that anybody, well, I shouldn't say anybody, people with a certain skill set like Bret can take those interfaces and integrate them with their own platform, in this case Azure. And I think that's what Bret did in this instance. I believe you used REST originally. That's right, Bret?
Yep, I was leveraging the REST API.
Yep.
Now, Bret, talk to me just a little bit about it. I think I've got the gist. They've already got a management system, and tell me how is it that Azure fits in?
Well, actually, I'll tell you what. I've got the setup here that we built for the solution, so it might actually be easier if I just sort of walk through that, both from the hardware and the Azure side. So I'm going to start by moving my camera down here. So. See here.
Yeah.
All that in frame.
Looks good.
Cool. All right. So Josh was talking about RPMA. And so this proprietary wireless protocol that they have, this is an RPMA access point. So if you were out in the field and looking at a tower, where an RPMA access point was installed, this is kind of what you'd see mounted up on the tower.
So I'll just jump in real quick. I mean, that's essentially the heart of our base stations that we're deploying on telecoms towers throughout the world to beam out RPMA coverage. And you can see it's about the size of a shoebox, roughly, I would say. But it's pretty powerful. We can cover, in certain conditions, about 300 square miles with that one box and support thousands and hundreds of thousands of RPMA devices just with that one access point. So
okay, so the light that I'm turning on the other side of my mountain here, I don't need a device like this?
No. So this is going to be on that tower somewhere within a 300 square mile radius.
On top, maybe the tower's on top of the mountain and you got coverage on both sides. I mean, in that instance. For instance, in the Dallas-Fort Worth area, it's a pretty wide area. If you've ever been there, it's about 2,000 square miles. We've covered that entire Metroplex area with just 17 of those access points. Compare that to cellular, they have about 1,500 towers in that same area. So it speaks to the differences in terms of the capacity.
Yeah,
that's pretty incredible.
Yeah, so these guys are, again, sort of what you need to talk to, or where it's going to receive sort of the RPMA messages, and then it goes out over its backhaul, right? So if you're on the tower, you'd actually be most likely connected up, over Ethernet directly to the internet. But Ingenu was nice enough to give me sort of this mobile little demo kit. So instead of plugging directly into Ethernet, I'm going over a cellular backhaul and using just AT&T or Verizon. So that for my demo kit, I can get up to the internet. But just think of this as Ethernet, right? It's the only reason it's cellular is so that I can demo it wherever I want to, right?
And you keep it right there next to your desk. That's
sure,
nice, Bret.
I
you won't be having any babies.
We don't encourage that.
So this is set up for the demo, yes. Anyhow, so this antenna here is, sort of talking RPMA. And so I now need a device in the field. And so for my demo setup, I've just got a little microcontroller and a sensor. So for my demo, it's just an Arduino and then this little, DHT11 temperature humidity sensor. But it could be any sensor. It could be any microcontroller. It could be any actuator. I could be having motors or buttons or whatever, lights, fans, whatever, you got it hooked up to this guy. And so my microcontroller needs to be able to get that sensor data and push it up to me so I can get it. And so what I need is a wireless solution, right? And if I were in a building, I could just use Wi-Fi or something like that. But we're talking about devices in the field where cellular is expensive from a power perspective. This might be a device that I want to leave in the field with a battery attached, and I want to get as much battery life out of that as I possibly can. So RPMA gives me the advantage of being able to use lower power on the device itself to be able to establish that communication. And so I need an RPMA radio to talk to it. And so this little silver can here is basically my RPMA radio. But Ingenu gives it to you on this easier to work with prototyping board called a dev kit or a RACM. Right, so this is my Reference Application Communication Module, or RACM.
Very good.
It's really that silver can there is what's talking the RPMA protocol over here to the antenna, and then being able to get me up to the backhaul off to Ingenu's Intellect platform, right?
Yeah.
And that's sort of the setup. In fact, while I'm doing this, I'm going to go ahead and I've just got a little hand warmer here you buy at the sports store. I'll just place it over my temp sensor there so we can start to see numbers crawl up when I get there. But let me go show my screen.
Yeah.
So what's here is really that overall architecture that we built out, right? And so if you sort of walk through what I was just talking about, I've got this microcontroller with sensors, talking over the RPMA radio. That goes over the RPMA protocol up to that white access point that I was just pointing at. And then through its backhaul, it gets up to Ingenu's Intellect platform. And so at that point, if you're an Ingenu customer, you've got your device sensor data sitting as bits in a bucket, so to speak, up in Intellect. And the way that an Ingenu customer would then typically go get that data is through one of two different APIs. I've got a HTTP-based REST API, or I can use ANQP. And so at that point, the customer would come in and use one of those protocols to retrieve that data. And so now the customer's got that data payload, and it's really up to them to go do something with it, right? So like Josh talked about, as you want to start doing analytics or reporting or, activations based on that data, that's up to the customer to sort of complete that stack. And so Azure, of course, has a ton of tools to help customer do just that. So Ingenu's done a fantastic job of surfacing the message. Now we just need to be able to ingest that message and go do something with it. So what this project did is basically mimicked that same customer behavior, but inside an Azure function. So spun up an Azure function and used that same REST API to pull that message up into Azure. And so now my Azure function has the data, and then to get it into my pipeline, I turn around and push that into an IoT hub. And you could say, well, why am I going through the IoT hub? You could just push it straight into a database or something like that. But this gives me sort of a single ingestion point into my data stream. So I could now still be pulling messages in from other devices that maybe do have direct Wi-Fi connectivity and didn't need to be going through the RPMA stack.
Yeah.
Right. So
and plus there's a whole pipeline that is already well documented and set up, and you're going to be shoehorning all of these additional services later if you don't go through the hub. Let me ask you about the function. How do you trigger the function?
So the function is, in this case, timer-based.
Okay.
Because, again, that's really the customer behavior. Is the customer on their own schedule is going to decide when to come in and pull those messages. So for me, I set that function up to run every 10 seconds, I think, by default. Now, in fact, the device is only sending data every 30 seconds. And that's something I talk to a lot of people about, with IoT is people tend to think they want real-time data.
Yeah.
You really don't, right?
No.
Knowing how hot it is in my garage even twice a minute is just too much information. If I knew how hot it was in my garage every 15 minutes, it would still be too much information.
Yeah.
Once an hour is probably about the detail of grain that I need,
Or you want it.
Yeah,
or you want it event triggered, right? Probably if you hit a threshold or parameter, then you get that, when you really need to know the information is when, I completely agree.
Yeah, don't talk unless you need to. So, an RPMA is really sort of geared towards those lower bandwidth. I'm not going to be sending my video stream over RPMA. This is really tuned better for sort of those devices that are going to be sending discrete values, over reasonably timed periods. That doesn't mean you can't send every second. You can. But it's geared for devices that we want to live longer in the field on lower battery power and things like that. And so, I shouldn't say it's geared for, but it fits well for that scenario.
Yeah. So it's not real time. It's near time. Let's call it.
Right. Yeah.
And now that we have it into Azure and you have it flowing through the hub, I mean, now the sky's the limit.
Right. Exactly. That's where this beautiful flower of Azure just blooms. And you get everything behind it. So for a lot of IoT Hub solutions, Stream Analytics is just sort of the go-to next step. And Stream Analytics is a fantastic service that we have in Azure because it can watch that stream of messages that's coming in. Now, in my demo, I've just got one sensor, right? But imagine this were sensors, distributed throughout, Dallas, let's say, that metro that Josh was talking about earlier. And so I could have thousands of devices with, 2 or 10 or 100 sensors each, piping this data up. So it could be significantly more data. And so Stream Analytics can watch that stream, and I'm using it to do 2 different things. One, I'm going to have it sort of create what we call the cold path, take all of the data, whether it's of concern or not, and just pipe that off to an Azure SQL Database. And that's going to be sort of my reporting store. So I can now do long-term analytics or anything else that I want to on top of that. But in situations where the temperatures are anomalous, in my case, if the temperature reports is higher than 90 degrees Fahrenheit, I want to know about that. And so Stream Analytics can take those messages and send them off somewhere else. And in my case, I'm just sending them off to another queue, or more specifically, an Azure Event Hub. So the messages that are in there are alerts. Something's wrong. Somebody needs to pay attention to that.
Sure.
But now that
and then on the other side of the Event Hub, you can do anything. Right.
Right.
I mean, it's just one of those things where, and who knows what will dream up next, and it'll all be there sitting on the Event Hub. This is great. You know what's great about this, and I got to be honest, Bret, is your graphic here is really terrific because it really shows the ambiguity, or it takes away the ambiguity between the IoT Hub and the Event Hub, and how they just have different intents and different roles in a solution. It's great.
Yep.
Keep going. I hated to interrupt you. Keep going.
Oh, no problem. Yeah. So, well, and in fact, back to that point, an Event Hub is actually a fantastic message ingestion solution if all you really care about is unidirectional, messaging. I only care about getting messages into Azure, and I don't care about identifying individual devices. Yeah. But in an IoT scenario, we often care a lot more about the individual device. I want to be able to secure the individual device, and I need a back channel back to it. And so IoT Hub gives me that device level security, as well as bidirectional communication, device management, a whole bunch of other cool stuff that's very specific to IoT scenarios. So, but anyhow, so.
No, I get it. Wait, by the way, do you have bidirectional communication going on here?
We're going to get to it.
What? Okay, go on.
So now that the data is sitting in my database, like I said, the nice thing about that cold path is that now I can report on it. And sort of the typical way that we display data these days is, through a web application. So I spin up an Azure web app, and in this case, it's a Node.js application, but it could be .NET or, Python or Java or whatever the heck you wanted to. And so it's going to query that SQL data, and now I can display that data in a tabular format, off in the browser. However, I can now also leverage some other Azure services like Power BI Embedded. So, and start to build sort of BI solutions on top of that. So I can take things like charts and through the Power BI Embedded platform, embed those, back down into that browser as well. So that's sort of the cold path. I've got the data up now, and I'm able to turn around and report on that. So that's actually live. If I flip back over to my browser, so this is that website here. Remember, I put the that heater on my sensor, and this is actually a spike from earlier when I was testing just to make sure it was live. So let me just refresh the page here.
I see it. It's Power BI Embedded.
Yeah. So it's pulling fresh data in. And so here's that earlier spike when I was testing. This is while we were chatting. And then when I put that heater on, it started ramping up here. And so that's telling me I'm now at, 93, 95 degrees Fahrenheit.
Yeah.
And that's over the 90 degrees threshold that I had set inside my Stream Analytics query. So at this point, they should have been sending messages off to my Azure Function, to the Event Hub. And I'm over here in the Azure portal. And this is actually the function that we were looking at that's doing that read from REST, right? In fact, sorry, this is this one. This is the function that's reading in from their REST API, from the Intellect REST API, and then running every 10 seconds. So this guy is the one that's set up to trigger every 10 seconds. And so I can see that the last time it checked in, it just ran. It didn't pull any new messages in. So it runs every 10 seconds, but the microcontroller is only sending every 30 seconds. So it'll every now and then it checks in and says, oh, there's no new messages. But when it does get a message, it actually sees the message coming in, and in there I can see the temperature and the humidity values that were being published up. And so I can see those are high temps right now. I think the one I just had highlighted was like at 98 or something like that. So yeah, right there. So those messages should have been getting forwarded by Stream Analytics off to the Event Hub, and then this function gets triggered automatically by that Event Hub. So in fact, if I look at the integration on that, instead of being a timer, it's just listening on that Event Hub, on my Ingenu Alerts Event Hub. So whenever a new message pops in, that function just automatically kicks off. And what it's doing then is basically sending messages back downstream. It's sending what Ingenu calls a downlink message. So it sends the message back down to the device. And so if I actually switch back over to the camera, actually I need to get this slightly more in view here. There's actually a little LED right here on the Rackham board. And so right now that's kind of how I'm surfacing the alert. Let's say there's an attendant, near the device, and when it's over temp, I'm going to flash this LED.
I see it.
Hey, you're hot. Go turn the fan on or something like that, right? So that's that back channel. That's that downstream communication that's going on there.
Just imagine the back-end complexity to make that LED flash. That's incredible.
Right. Now, and again, in a real-world scenario, that could actually be an actual alert. We can also, through Ingenu's, through the Intellect platform, support things like email alerts where we notify somebody out of band. But it could also be coming back through to the device and doing something like turning the fan on to cool the room down or something like that.
Yeah, that's a great point.
So,
and I mean, I'm a farmer, and my farm has 120 irrigation devices. Each one can have a tiny little sensor that's looking for whatever. Each one can be connected to this network then in a real easy way, low-cost way. And I could have all kinds of logic going on here, not just monitoring for how well it's working, but like you're demonstrating, monitoring for possible problems that can save me a couple $100,000.
Yep, definitely.
Yeah. Absolutely, and we are supporting some applications in the smart architecture space, agricultural space. Excuse me. So smart city and areas like that have drawn so much attention in recent years. But kind of the exact opposite of that is doing things like helping farmers and others in those areas to get to be alerted when these things happen and to maybe monetize some aspects related to their devices out in the field.
Yeah. Talk to me a little bit now, Josh, about like power requirements and things that are different about using your technology.
Well, yeah, I mean, there's several that I kind of noted. I mean, I think one that Bret alluded to was battery life. Power consumption has been built into every layer of our protocol, and therefore we do things to make sure that devices that Bret mentioned can be out in the field for 5, 10, 15 years, running on a battery in some cases. Sure. And that obviously just it results in a tremendous ROI for our customers. That ROI for these applications can go down tremendously if they have to be out there every month, either charging or replacing a battery. And I should note that RPMA has been utilized in some private network scenarios for 10 years in some cases. And so this isn't just theory. This isn't something we've just sketched out on a napkin. Right. We actually have devices going out there and supporting that sort of those sorts of use cases. So battery consumption is obviously a very key one. I kind of touched on coverage, and our capacity there with just the access points, but our ability, because we have a high link budget in our technology, to really connect devices in areas where other wireless protocols can't reach. You know, subterranean locations, basements.
Wow.
We have recently connected soil monitors in sugarcane fields in Florida. I don't know if you ever walked through a sugarcane field in Florida, probably not, but if you have, it's an incredibly dense environment, sugarcane growing, 10 feet or higher. The ability to kind of penetrate that type of environment is really another area where RPMA stands out. One other thing I kind of would touch on at a high level is the network longevity issue.
Okay.
Really just incredibly important, again, so that our customers can really experience that ROI. If you've been operating on a device on a 2G network in recent years, you're probably facing a sunset where you're going to have to go out and grab that device, put in a new module, whether it's a 3G or 4G module, and that's considerably tremendously expensive when you're talking about tens of thousands or even millions of devices.
That's
Again,
right.
RPMA is built so we're backwards compatible. Your device that's out there working on RPMA today, we guarantee it will operate out there, 15 to 20 years from now. So those are just some of the things that, at the high level where we think are really some of the areas we stand out from the competition that's out in the market today.
A couple of things that are in my mind, I can't help but just wonder, things about latency and bandwidth.
Mm-hmm. Yeah, I mean, latency for us isn't going to be in the milliseconds. It's going to be in the seconds. But I think Bret would probably attest that's good enough for most of the applications that we're talking about. I think most of the sectors we're targeting, that's a satisfactory performance. And bandwidth is not going to be high like a high bandwidth LTE environment. But again, we see that about 85% of the market of IoT devices use 3 megabytes or less a month, and that's the kind of the segment that we're targeting. And really, as we see the IoT grow into a variety of new applications, we're seeing the preponderance of those devices have very low data and bandwidth requirements because they're simply sending some of these alert messages when something goes wrong, or on a daily basis, they're just sending some very small packets of information about, temperature, humidity, things of that nature, pressures. So technology, that you don't need a big fat LTE pipe to service these devices. What you need is something that's more appropriate, and then you get to the other advantages I already talked about, like low power and so on.
It's incredible. If you're not in my market, what do I do?
Well, you contact us, and you can reach out to us on our website, and really request what Bret had there basically was an exploration kit, and as he kind of talked about, it's two key components. It's one of our access points, which can kind of get you onto the RPMA network, and it's one of our RACMs or dev boards, which can allow you to kind of test your device or your application on RPMA. And Bret did this in a matter of days. We certainly have a team here in the San Diego office that is willing to support developers that want to build something on RPMA. So I would encourage you to reach out to us. You can make a request through our website for an exploration kit, and we'll go from there. But I think Bret would tell you it's relatively simple as these things go to kind of get up and running with RPMA.
All right, let's see. And your website is just so developers listening, they're like, okay, and where do I go? It's Ingenu.com?
Yeah, Ingenu.com. Yep, Ingenu.com. So please look us up, check us out. We have a variety of white papers, blogs, other information just that really dives deep into the technology stuff we're not getting in today. And if you have time, there's 80-page documents on there. If you want to know everything you can about RPMA, that's available to you. We're not trying to hide anything. We think we've built one of the best technologies available for the IoT, and we certainly welcome any questions or feedback for anyone that explores the website.
Nice. Bret, give me a level check here. It sounds like Josh is saying this is super easy. How easy is it? Is this a reality check?
Well, it's even easier now that I've already written this code. So, so getting into the RACM was easy because it's a pre-built solution, and it's already got software running on it that you can configure. to sort of meet your prototype needs. So in my case, I was able to go in, run a couple of scripts, tell it, hey, I want you to just listen for messages off the serial connection and forward them off, to the network for me. And so it was pretty easy to get that Rackham configured. I used a little bit of my own, sort of microcontroller and sensor, knowledge, but playing around with, at least from a prototyping perspective, devices like Arduinos and these sensors are, that information is readily available, and, kids in elementary schools are doing it, so you can certainly play around with that stuff. So I'd say from an accessibility perspective, it was pretty easy. And I have this solution up in Azure, so we'll give links into the show notes, etc. But aka.ms/Ingenu 2 Azure. So aka.ms /Ingenu to Azure, and that'll get you up to the GitHub repo that has all the function code and stream analytics codes and my slide decks and all that kind of stuff.
I know we already said it, but just as a reminder, what you made so clear is once it's in Azure, then it's up to you what you do, right?
Yeah, really. Once you get that that message into IoT hubs, you don't have to follow my path. If you don't want to use Stream Analytics, if you want to use functions, or IoT hubs has another really cool feature now that didn't exist when I started this project called IoT routes, where you can just direct messages, directly into an event hub or something like that downstream. Use whatever the heck you like. I had a Node.js app, web app. You can write yours in, ASP.NET. Go for it. So it's really just the entire stack is now available to you. And IoT hubs is just, as I say, sort of that gateway to get you into it.
Yeah. And just one point I want to add real quick is, Rackham is our development kit today. Right now, we're working with a variety of partners. They're actually going to develop Arduino boards with RPMA built into it already. So essentially eliminating a step that Bret had to go through, and we expect those out in upcoming months, and those will be available through our website. So please keep checking and contact us directly if you have any questions. But we want to make it as easy for developers to work with RPMA, and that's another step in that process.
Well, and flip side, that Rackham board, has a Freescale microcontroller on it. Right. ARM Cortex M4 processor. So if you are, an embedded type dev, you can write that hardware level code.
That's a good point.
And you don't have to use the Arduino. I just went the Arduino route over serial because I had to spin it up in a couple of days, and I'm not a microcontroller, embedded type dev on a day-to-day basis. So, but somebody who's looking at building a real product, may want to go, more towards that, microprocessor type.
Or just wait a month or two.
Yeah, or just wait a month or two.
Right. There you go.
Things just get easier. Boy, they really do. It's so exciting, so overwhelming, and then so awesome at the same time. You know what I mean? Yeah. It's definitely inspiring. Josh, listen, I think the possibilities are crazy endless. It seems so realistic now that I could have these things out in the field, because that's always bothered me. I'm like, how am I going to talk to these with some super duper Wi-Fi network? That seemed ridiculous, and cellular, as we all know, is crazy. And so, wow, man, I'm glad we had this show. This is awesome. I've got a million new ideas.
Yeah, you're absolutely right. It's all about making it easy for the customer, and we think combining our network technology with a platform like Azure, does that, because there's a lot of great ideas out there. But we need to make it easy for people to build IoT and build IoT devices. And again, I think this enables that, certainly. And any IoT solution consists of three parts: the device, the network, and the platform. And we're integrating two of those right now for you. And now it's just go build some devices, and you're up and running.
Brilliant. Josh, thanks for being on the show and talking to us about this. This is excellent.
Absolutely. No, I appreciate it. I think, Bret's done incredible work. I can't speak to how wonderful he's been. It's been a great partner to have for us, and he's taken on so much of this work on his own. And we're really appreciative of that. And I think the end result, speaks for itself. I think it's a tremendous value for developers and for potential end customers that want to build their applications on RPMA.
I feel the same way. I mean, who can describe how wonderful Bret is? I'm right there with you.
Right.
No kidding, Bret. You did it again. Good job. This is an awesome and inspiring project. Thanks for being on the show today.
You bet. Thank you.
We'll see you guys.
Take care. Thank you.